So we did amine. So in today's class we are going to discuss amide. So amide का जो basic functional group है, basically this is C double bond O and nitrogen. Okay, and there should be there may be H or there may be R group which is attached to the nitrogen atom. And nitrogen atom is having one lone pair, okay? Because when the nitrogen is having three bonds, so it has one lone pair. And when the nitrogen is having four bonds, so it has a positive charge. When nitrogen has two bonds, it would be having a negative charge. Let's suppose, if you remember, when there are three bonds, so zero charge. When there are four bonds, so positive charge. When there are two bonds, so negative charge. Okay. If you can see that there are three bonds with this nitrogen atom, so this is the reason this nitrogen is having no charge. Okay. Okay. We discussed ammonia, we discussed amine, primary amine, secondary amine, tertiary amine. I told you that amine was basic, ammonia was basic, but amide is not basic. Base has to donate its lone pair. Okay, the nature of the base is that it has to donate its lone pair. Like if you can see, okay, sodium is a metal, lithium is a metal, potassium is a metal, rubidium is a metal. Metal has to lose electron. If the metal is going to lose its electron easily, so I would say, okay, this is metal. And if the substance is not going to lose its electron, so I can't say that this is a metal because metal has a tendency to lose electron. Same goes with the bases. Base has a tendency to give a lone pair. Okay, but the thing is कि इसका जो lone pair है which is delocalized like this, so it's not available. It's not available basically. If the amide is not going to give its lone pair to someone else, so how can I say that this is a base? If this is a base, it has to give its lone pair. It's mandatory. It has to give electron pair. Okay, so amides are solid at room temperature and amides are soluble in water because amides are polar in nature. Amides have a positive or negative charge. As you can see, the nitrogen is having one lone pair, which makes it polar. And obviously, you know that the water is also a polar substance, so it would be soluble in water. We have few family members of amide like ethanamide, then we have propanamide, then we may have, you can say, propanamide. After propanamide, I can say I have butanamide. Like this would be CH3, then CH2, then CH2, then C double bond O, and then NH2. This is called butanamide. Then we have pentanamide, etc. So I want to prepare amide. So it's a general reaction. Whenever you are going to react your acyl chloride with ammonia, you would be getting amide. This is additional elimination reaction. Addition or or basically addition and elimination reaction. इस इसमें ऐड भी हो रहा होता है और एलिमिनेट भी हो रहा होता है. कैसे? Basically, this is your acyl chloride. It's going to react with ammonia. This would be released. This would be eliminated. This would be eliminated basically in the form of HCl, and the rest of the molecule is joined to this carbon. So this is amide. This is amide, right? Uh, Also, if your acyl chloride is going to react with amine rather than ammonia, it would also be giving you amide. Let's suppose this is your acyl chloride, this is your amine. Ultimately, HCl would be released, and the rest of the compound would be joining through this carbon. So this is your amide. So basically, in amide, this is the functional group. In amide, this is the functional group. तो सी डबल बॉन्ड ओ और एन एच ये फंक्शनल ग्रुप होता है किसका? एमाइड का. तो इट्स मैंडेटरी. तो अगर कभी भी आपको एमाइड बनाना पड़े तो रिमेंबर यू हैव टू टेक एसाइल क्लोराइड एंड यू हैव टू टेक एमाइन और यू कैन टेक अमोनिया. तो जब भी ये दोनों रिएक्शन करेंगे सो यू वुड बी गेटिंग एमाइन, यू वुड बी गेटिंग एमाइड, सॉरी एमाइड. So this is the functional group for amide. C double bond O and NH. C double bond O and NH. Okay. Then after the formation of amide, after the preparation of amide, we can hydrolyze our amide that we have prepared in this reaction. We can hydrolyze it easily. Like if you remember, we used to hydrolyze ester. Esters can be formed by the reaction of alcohols and carboxylic acid. So if you are going to hydrolyze your esters, so you would be getting alcohols and carboxylic acid again. You would be getting alcohols and carboxylic acid again. Same goes with amide. If you are going to hydrolyze amide, so you would be getting the reactants again. There are two types of hydrolysis as it was in esters: acidic hydrolysis and the basic hydrolysis. In acidic hydrolysis, we would be adding acid as a catalyst, and in basic hydrolysis, we would be adding a base. So, uh, obviously, acid is used as a catalyst. Let's suppose if you are going to do hydrolysis and you are not going to add acid, so ultimately, as you know, that acid is a catalyst. So a catalyst lowers the activation energy and increases the rate of reaction. So the rate would be slower if you are not going to add a catalyst. If you are not going to add a catalyst, the rate would be very slow. So to increase the rate of reaction, you are supposed to add a catalyst, that is your acid. So if this is an amide and you are going to hydrolyze it, so remember bond यहाँ से break down होगा. तो जब bond यहाँ से break down होगा, तो ultimately you would be getting your amine again. You would be getting your amine again, and you would be getting your carboxylic acid again. It's very simple. It's very simple. Okay. You would be getting your carboxylic acid again, and you would be getting your amine again. Or also I can say कि I would be getting my acyl chloride again. Okay. I would be getting my acyl chloride again and amine again. So if you are going to react them together, okay, so obviously you would see K HCl, okay, so HCl would be released, okay, and ultimately you would be getting your amide again. It's very simple. It's very simple. So बेसिक हाइड्रोलिसिस में क्या होता है? बेसिक हाइड्रोलिसिस में इन बेसिक हाइड्रोलिसिस you know के you have this reactant is the same, okay, reactant is the same, or you can say okay, this is water, okay, this is water, and we are going to use a base as a catalyst. We are going to use base as a catalyst rather than acid, okay, rather than acid. तो बजाय इसके कि आपका ये बने, ये बन जाता है, ये बन जाता है, दिस इज योर सॉल्ट, दिस इज योर सॉल्ट, बिकॉज आपने उसमें बेस यूज किया है. अच्छा, बनता पहले ये है, like first of all you would be getting this, but in the presence of sodium hydroxide, in the presence of sodium hydroxide, the sodium would be attached over here. So ultimately it would be called, this is the salt. I can say that this is the salt, okay? And again the amine is produced, okay? So this is the difference between the acidic hydrolysis and the basic hydrolysis, okay? Then if you are going to reduce your amide, if you are going to reduce your amide, so you are supposed to use the reducing agent. So the reducing agent is LiAlH4 in dry ether. It's the reducing agent. Or ultimately, reduction is the loss of oxygen and the gain of hydrogen. So this oxygen would be removed, reduced, and hydrogen would be added over here. So I got amine again. So if you are going to reduce your amide, if you are going to reduce your amide, so you would be getting your amine, you would be getting your amine, okay? So the reduction of amide gives amine. Okay, it's very simple. Then we have amino acid. It's the last type of organic nitrogen compound because it's also contain nitrogen. So that's why we are going to discuss it. So amino acid, as the name indicates, that it's a mixture of two things. Number one, we have amine, and then we have acid, that is carboxylic acid. Since we are studying organic chemistry, so the acid would be carboxylic acid rather than any type of acid. Let's suppose we have HCl, we have H2SO4, we have H3PO4, we have HNO3. So we would be having carboxylic acid. This is an organic acid. Or if in the same compound you are getting acid and the base, amine is the base, carboxylic acid is your acid. So ultimately I can say the whole amino acid is neutral. The whole amino acid is neutral. Okay, so amino acid is having amphoteric nature, just like a water. It can act as an acid, it can act as a base. When amino acid would be reacting with an acid, so it would be acting as a base. And when the amino acid is reacting with the base, it would be acting just like an acid. So that's why I can say amino acid has a dual nature. It's amphoteric in nature. This is the structure for amino acid. If you can see that this is amine and this is carboxylic acid, the both functional groups are attached to the carbon, and this carbon is having one H and one R, and this is the chiral center. As you know that, okay, you have discussed in AS level, like the optical isomerism. For optical isomerism, there should be a chiral center. Chiral means that the carbon which is attached to the four different groups. Chiral means that which is attached to the four different groups. This is called chiral center. So if you can see, K, if the pH is 7, if the pH is 7, which is the neutral pH, so this is the structure for amino acid. अमीनो एसिड में ऑटो प्रोटॉन ट्रांसफर होता है. इट्स ऑटो ट्रांसफर. आई एम नॉट रिस्पॉन्सिबल, यू आर नॉट रिस्पॉन्सिबल, the condition is not responsible, the environment is not responsible. It auto dissociate, like you can say, transfer the proton in an environment, in its solution. you know this is an acid. Acid has a tendency to lose proton, and this is the base, and base has a tendency to accept the proton. So when this carboxylic acid gives its proton, so this amine would accept this proton, so ultimately you would be getting this structure. After giving H plus ion, you would see it would be C double O minus, and after getting NH, after getting one H plus, NH2 would be converting into NH3 positive. So this is called Zwitter ion. This is called Zwitter ion. This is whole and soul electrically neutral. Okay, because ke, like, okay, if the same compound is having positive or negative charge, so ultimately there would be no overall charge because they would be canceling each other. Okay, so this is called the Zwitter ion. If the pH is 7, so amino acid exists in the form of Zwitter ion, and the Zwitter ion is neutral. I am showing the positive and negative charges. Obviously, they would be canceling each other. So as a result, this would be neutral. As a result, this would be neutral. So at pH 7, amino acid is existing in the form of Zwitter ion, which is neutral. And if the pH is greater than 7, like the basic environment, basic means that I am increasing the concentration of OH minus ion. I am increasing the concentration of OH minus ion. So if I would be increasing the concentration of OH minus ion, so the OH minus ion has a tendency to accept proton from this. So ultimately it would be converting again into NH2, and this would remain the same because OH is having a negative charge. Negative cannot attack on the negative side. Okay. So if the pH is greater than 7, your Zwitter ion would be having an overall charge that would be negative. But if the pH is greater than 7, less than 7, this shows that this is an acidic environment. Acidic environment में क्या होता है? Concentration of H plus ion is higher. When the concentration of H plus ion is higher, so which means that H plus ion would be attacking over here because it's having a negative charge. This side would remain the same. As you can see, this remains the same. It would be converting into the carboxylic acid again. So now if you can see this, there is a whole and sole positive charge on this. So it depends on the pH. It depends on the pH. If the pH is 7, so it's neutral in the form of, it exists in the form of Zwitter ion. If the pH is greater than 7, like the basic environment, okay, so the concentration of OH negative ion is higher. Ultimately, it would be attacking on this. And if the H plus ion is higher, so it would be attacking on the negative side. So it would be forming this carboxylic acid again. And this positive charge would be the overall charge of this amino acid. Okay. Then multiple amino acid exist. We have alanine, we have aspartic acid, we have cysteine, glutamic acid, glycine, lysine, phenylalanine, serine, tyrosine, valine. Basically, it depends on the R group. It depends on the R group. If you are going to attach CH3 over there, so it would be forming alanine. If you are going to attach this over there, so it would be forming aspartic acid. The rest of the portion of the molecule would remain the same, but you can only change the R group. You can only change the R group. So to change the R group, you would be forming different amino acids. If you are going to attach this whole portion to this carbon atom instead of R, so ultimately your amino acid would be phenylalanine. So it depends on the R. It depends on the R group. So these are different R groups as you can see. Okay. Or like you told that amino acid is having a dual behavior. So you are supposed to give a proof. Okay, why this is having a basic behavior. If this is having a basic behavior, it should react with an acid. So when this amino acid would be reacting with this HCl, okay, with this HCl, so ultimately this acid would be attacking on the basic portion, would be attacking on the basic portion, like it has a lone pair of electron. It has a lone pair of electron, ultimately just like that. So when it would be attacking on this basic portion, so they would be forming a salt. They would be forming a salt just like this. Or if your amino acid is going to react with this alkali, so this alkali would be attacking on this acidic portion. So again, it would be forming a salt. Again, it would be forming a salt. As you know that this acid would react with this base, would react with this base. Okay, so that's why it would be forming a salt just like that. It's very simple. It's very simple. Okay, this OH, basically this OH, let's suppose this OH and this H, okay, would be reacting together to form water, H2O, and Na would be attaching over here. COONA. Okay. So this is your salt. So it's the proof that amino acid is having a dual behavior, because amino acid is going to react with HCl and amino acid is going to react with your alkali. It's very simple. So this reaction shows the basic behavior of amino acid because it's reacting with acid, and this reaction shows the acidic behavior of this amino acid because amino acid is going to react with alkali. It's very simple. Okay. So let's suppose let's suppose we have this amino acid. This is called alanine. Okay. And this is another amino acid. This is called serine. Okay, we have two amino acids. So if the two amino acids are going to react together, ultimately, uh, basically, this is H and this is also H. So, when the two amino acids are going to react together, when the two amino acids are going to react together, so the first amino acid, which is having a basic part, would be reacting with the acidic part of another amino acid. Ultimately, this is an acid base reaction. This is an acid base reaction. This is your base, okay, or this is your acid, okay. This is your base and this is your acid. So ultimately, this is an acid base reaction. So the water would be released, and the rest of the molecules are joined together just like that. And the rest of the molecules are joined together just like that. Okay, it's very simple. So he would be giving you different amino acids, and you are supposed to react them together, you are supposed to add them together. Obviously आपके पास एक नया प्रोडक्ट बनेगा और उसमें आपको क्या नजर आ रहा होगा. You can see this is an amide linkage. You can see that this is what, this is amide, this is your amide linkage. Okay, this is your amide linkage. तो जब भी दो अमीनो एसिड आपके रिएक्शन करेंगे, जब भी दो अमीनो एसिड आपके रिएक्शन करेंगे, तो याद रखिएगा आपके पास एक अमाइड लिंकेज बनेगा. अभी तो मैंने आपको दो अमीनो एसिड दिए हैं ना कि यार आप इनका रिएक्शन कराओ. मैं आपको तीन एसिड भी दूंगा. मैं आपको तीन अमीनो एसिड भी दूंगा. कौन कौन से? मैं कहूंगा यार आप बनाओ जरा एला सर ग्लाय, एला सर ग्लाय. लाइक आई मीन टू से कि आप इन दो तीनों को कंबाइन कराओ. एला इज एलानीन, सर इज सीरीन एंड ग्लाय इज ग्लाइसिन. तो सबसे पहले आपको क्या देखना है, इस एलानीन का स्ट्रक्चर. आप क्या करोगे, आप क्या करोगे, आप पहले तो नॉर्मली जो होता है आप उसका स्ट्रक्चर बना लोगे इस तरह से. अमीनो एसिड जो होता है जस्ट लाइक दिस, यहाँ पे H होता है और इस R की जगह क्या आएगा मैं उस टेबल से जाके देख लेता हूँ. इफ द अमीनो एसिड इज एलेनीन सो द R ग्रुप शुड बी CH3. तो पता है मैं क्या करूंगा, पता है मैं क्या करूंगा, यहाँ मैं लगा दूंगा CH3 ही प्लस. अब मैं बनाऊंगा सीरीन का स्ट्रक्चर. अब सीरीन के स्ट्रक्चर में मैं काम करता हूँ. पहले तो मैं नॉर्मल अपना बना देता हूँ कुछ इस तरह से. पहले तो मैं नॉर्मल बना देता हूँ. ये H हो गया. और R ग्रुप क्या होता है सीरीन के लिए, सीरीन के लिए जो R ग्रुप होता है, सीरीन के लिए जो R ग्रुप होता है वो क्या है, CH2OH. क्या होता है वो, CH2OH. क्या होता है वो, CH2OH. ओके, प्लस प्लस. अच्छा मैं एक काम करता हूँ, इसको ना मैं अरेंज करके लिख देता हूँ. इस CH2OH को मैं ऊपर लिख देता हूँ और इस NH2 को मैं यहाँ लिख देता हूँ. उसका फायदा मैं आपको बताता हूँ कि मैं ऐसा क्यों कर रहा हूँ, देखिएगा जरा। उसका फायदा हम आपको बता देते हैं कि हम ऐसा क्यों कर रहे हैं। इसका फायदा है बहुत, आपको अटैच करने में आसानी हो जाएगी। कैसे, देखिएगा जरा। अच्छा, एक और अमीनो एसिड मुझे भी बनाना है, दैट इज ग्लाइसिन। दैट इज क्या है, ग्लाइसिन। अब ग्लाइसिन के लिए मुझे क्या करना है, अब देखते हैं। लेट्स सपोज वी हैव, दिस इज H और दिस इज C डबल बॉन्ड O और H, और ये आपका है NH2। और R ग्रुप, और आपका ग्लाइसिन के लिए R ग्रुप क्या होगा, ग्लाइसिन के लिए आपका R ग्रुप, ये सॉरी, ग्लाइसिन के लिए आपका R ग्रुप सिर्फ H होगा। मैंने यहाँ पे क्या लगा दिया, H लगा दिया, ओके। अब क्या होगा कि ये वाटर निकल गया यहाँ से, और ये वाटर यहाँ से निकल गया, ओके। फाइनली आप अटैच कर दो इसको। फाइनली आप इसको अटैच कर दोगे कैसे, H3C और ये C और ये H और ये C डबल OH और ये N और ये H और ये C डबल बॉन्ड O, फिर ये C, फिर ये CH2OH, फिर ये H, फिर ये N, फिर ये H, फिर ये C डबल बॉन्ड O, फिर ये C, फिर ये H और ये C, नहीं, और ये N, और फिर ये H, और फिर ये H, ओके हो गया जी। तो आपने क्या किया, इसमें तीन अमीनो एसिड्स को कंबाइन कर दिया विद द लॉस ऑफ वाटर मॉलिक्यूल। दिस इज कॉल्ड एलासरग्लाय, क्योंकि आपने एलेनीन को, सीरीन को और ग्लाइसिन को आपस में अटैच कर दिया है, ओके। तो इस तरह से डिफरेंट डिफरेंट अमीनो एसिड्स को आप क्या करोगे, ऐड करोगे, रिएक्ट करवाओगे, फाइनली वाटर मॉलिक्यूल रिलीज होगा और आपका प्रोडक्ट बन जाएगा, दैट्स इट। ये काम करना है। सो दैट्स ऑल फॉर दिस चैप्टर, ओके। और वी वुड बी डूइंग द पास पेपर, ओके जी, वी वुड बी डूइंग द पास पेपर। सो चलो जी।